Our goal is to find the limit of x to power square root of x as x goes to 0 from right-hand side. If you use direct substitution, we get 0 to power 0, which is indeterminate form. Let us take ln of both sides. Write y equals to x to power square root of x, and then take natural log or ln of both sides. Our goal is to simplify this as much as we can. So ln of y is equal to ln of x to power square root of x using algebra. If you have a quantity like u raised to power n and it has ln in front of it, you can take this exponent and write it in front of ln. So write square root of x in front of ln. ln of y becomes square root of x times ln of x. Now, if you take the limit as x goes to 0 from right-hand side, you get the following situation. Limit of ln of y as x goes to 0 from right-hand side is the same as the limit of square root of x times ln of x as x goes to 0 from right. In this case, your right-hand side is 0 times ln of 0 from right-hand side is negative infinity, but again, it is indeterminate form. Remember the behavior of ln of x. So for ln of x, this guy behaves like this. It hits x-axis at 1, but as x goes to 0 from right-hand side, the behavior of y is going down toward negative infinity. So that's how the limit of ln of x as x goes to 0 from right-hand side is negative infinity. So what should we do? Our goal is to write it the way that you can use L'Hopital's rule or anything similar to that. Let us write square root of x on the denominator. But how? On the left-hand side, you copy down everything you have. Nothing is changing. On the right-hand side, however, you can write it as limit of use division bar and then x to power a half on the denominator becomes x to power negative a half. And copy down your ln of x on top. X goes to 0 from right-hand side, or in simpler version, you have limit of 1 divided by square root of x. And on top, you have ln of x. And x goes to 0 from right-hand side. So if you plug in 0 from right-hand side, this guy becomes ln of 0 from right is negative infinity. And on the denominator, you have 1 over 0, which is also infinity. You can analyze the behavior of the graph of 1 over square root of x as well. It's not very difficult to see that. Your graph is just a little bit similar to what you saw in algebra as a reciprocal function. So this graph behaves like this. This is 1 divided by square root of x as x goes to 0 from right-hand side. As you can see, your y goes to positive infinity. So again, you have indeterminate form. You have negative infinity over infinity, but now you can apply L'Hopital's rule. So let us begin. The limit of ln of y as x goes to 0 from right can be written as the limit of the derivative of ln of x divided by the derivative of, let us simplify this as negative exponent. It makes it easier for us to do the computation, which in turns can be written as limit of 1 over x divided by negative a half x to power negative 3 halves as x goes to 0 from right-hand side. Can we simplify this further? This becomes the limit of, so here you have x to 3 halves minus 1, and you have negative a half on the denominator. You can simplify this further as well. So you get limit of x to power a half times negative 2 as x goes to 0 from right-hand side, which is nothing but 0. So what's happening here? We have the limit of ln of y as x goes to 0 from right-hand side equals to 0. What does it tell me? It tells me log with base e of y is equal to 0, or y is equal to e to power 0, which is 1. So the limit is equal to 1. It's a common mistake that students stop at this step and they say, hey, the limit is equal to 0. The common mistake to avoid is the limit of y is not 0. The limit of y is equal to e to power 0 or 1. X to power square root of x as x goes to 0 from right-hand side is equal to 1. This is what we are looking for. Again, please pay attention. This is one of the techniques, one of the methods to help calculate these types of limits. We have other shortcuts that we can use later.